fast with the FAAST team.
Hi, I'm Aaron Tippett. You might be a pilot, but have you earned your wings? Get started today at FAAStafety.gov.
Mooney 1041 Golf cleared to 19, Delta hold short on Delta at 19. Flaps 10, prop high RPM, mixture best power, pitot heat is required.
Mooney 1041 Golf, Florence Tower, stop right where you're at, traffic on short final.
Part of the issue people have with takeoffs is that they overthink the process. I like to say that airplanes fly themselves better than we fly them, and that's especially true on takeoffs.
Have you seen a perfect takeoff?
Probably not. Probably not.
I have never seen a perfect takeoff.
Let's see. Everything is nice and smooth, nothing aggressive, nothing jerky, and clean break from the ground, accelerate, climb out at 80 in my case. I guess that's the perfect takeoff.
Perfect takeoff for me is going to be a takeoff that's well managed and safe.
See, I like Simon's answer better. Just scrap mine. That's the right answer if there is one.
If your goal is to be perfect on speed, on attitude, on heading, everything else with a takeoff, you're going to be working really hard. And it's going to take you a long time to get there. The engine failure is what we're all worried about. What we're all bad at is directional control. You come on, line up with the center line, and one important thing to remember is to get the nose wheel straight before you add power.
On a 100-foot wide runway, on a 75-foot wide runway, it may not seem like it makes a difference, but it does when you're trying to take off on a 20-foot wide runway or something that for all intents and purposes looks like a sidewalk.
The biggest thing I see on nose wheel aircraft is yaw control.
What I notice is the feet are lazy. Basic things, like when we add power, we're going to need right rudder. Why? Because the nose will yaw to the left. Why? Because of torque. So what do? We add right rudder. So be ready with the right rudder, but don't over control.
And then as we transition nose up, isometric thrust comes into play. So now we need even more right rudder on takeoff. The biggest issue, as Jonathan has already expressed, it's the yaw control. We tend to be left of center. When we depart the runway, we tend to be skewed sideways, because we're using aileron to try and correct rather than rudder to correct.
Once you break ground, you know that you want to establish a pitch attitude that will result in a speed that gets you close to VY. So, if you've flown that airplane before or with any sort of experience, you should know about what that pitch attitude is. A takeoff is a visual maneuver, no doubt about it. So you're looking outside. Of course, instruments help you verify that your attitude is in the correct place, that your wings are in the correct place, that your speed's the correct value. And so what you do is look outside most of the time and then quick inside verifications on those instruments. The big secret is you need to be thinking ahead. So that starts when you apply power. You're thinking progressively farther in advance, so it's, okay, am I going to make this takeoff? Am I going to abort this takeoff? And you know those parameters ahead of time, so there is no ambiguity once you're on the runway. You've broken ground. Okay, if something happens now, what am I going to do? Am I going to land straight ahead? Am I going to try and climb out? Depends on the problem, obviously. One of every pilot's biggest fears is an engine failure on takeoff, and understandably so, because you don't have a lot of altitude to work with. And one of the ways to combat that is with a takeoff plan. Professional pilots are excellent at this. They have defined parameters in each part of the takeoff where if something will happen, they will take a certain action. And we can replicate that type of attitude, not necessarily to the specificity that they take or to the degree that they take, but the process by which they go by. So that's things like if you have an engine problem on the rollout, if you have one right after breaking ground, if you have one at 300 feet, 500 feet, whatever the numbers are. And every airplane and every pilot is going to have a different standard for this. Getting the takeoff right is important because if you think in terms of energy, the takeoff has a lot of energy. We're at full power. We might not be very fast, but we got a ton of power. And as we leave the ground, of course, we're very close, and there are lots of hard things that we could hit, which is not what we want to do. So the tolerances are lower. When you're at altitude and something happens, you have time, you have options, but that's not really the case with takeoff, and that's why you have to have a plan going into it. I think an easier route, and honestly, probably a better route, is to say, okay, I'm going to take off on or about this speed, I'm going to establish this pitch attitude, and I'm going to climb out on or about this speed after the pitch attitude establishes that.
Your airplane's takeoff performance is affected by a lot of factors. Some are environmental and some are mechanical.
There's other considerations that people get caught with, and that it's more than just density, altitude, because people are aware of that. It's the age of the aircraft, engine condition. If you take a brand new engine, brand new aircraft, it's got 100 hours, that engine is performing at peak and it's working, it's developing the proper horsepower. The older the engine, the lower the compression, the more dust, dirt that accumulates, oil. That is where a lot of people get stuck into not just density, where the aircraft just cannot take it because the engine is not developing its 100 horsepower the way it was designed in the first place. It's down to maybe 85, 89 horsepower. So right away, you don't have the same engine.
With this in mind, every pre-flight should include a plan for aborting the takeoff if things are not going as planned.
Once the takeoff begins, there's two phases. There's the part where you can safely abort. There's the part where you can't, and recognize the difference between those two phases. And there's a kind of a formula, a rule of thumb that you need 70% of your takeoff speed when you get halfway down the runway to safely make the takeoff. And if you don't have 70% of your required speed by the time that you reach the halfway point, then you must abort immediately. And that part is not hard to figure out.
Use your surroundings to help pick out a point beyond which you should not continue the takeoff roll. Your abort point could be a prominent landmark, such as a taxiway intersection, VOR, or runway sign or marker about halfway down the runway.
When we're talking about awareness of your situation, it's before you even get in the airplane. You can walk the runway. You can pick out a point that's halfway. You know what your rotation speed is. Figure out what 70% of that number is, and know that if you're not at that number by the time you reach the halfway point, abort.
A good approach means a good landing, and that's harder to do than it sounds.
It's an old maxim that's just so true that a good landing starts with a good approach.
It's so cliche, but it's true. I mean, a good landing does begin usually if you're flying the pattern at pattern altitude.
I mean, for me, it starts when you're flying back and you're thinking about, okay, what am I dealing with today? What strip am I landing on? What's the wind? What's the wind doing? What's the temperature? How do I feel? So if you have an issue that's developed, a mile final, whatever, half a mile final, if you don't correct that issue at that moment when it crops up, it will become a problem over the numbers. But the instant something comes up, it should be dealt with. And that will mean a good landing. So on slope, on speed, with a plan, with an exit strategy if you need one.
Airline pilots or in airline flying or commercial operations there's always a pre-landing brief done, and it's quite extensive. Even though we're flying small airplanes, we should have a proper pre-landing brief. And our pre-landing brief is that this will be a normal landing, runway 27. If it doesn't look right on the approach, if something comes out in front of us, or if we're not safely down within the first one-third of the runway, we'll overshoot. And that's our pre-landing brief. So we already have in our minds that if something isn't looking right, we already have it set what we're going to do. And with that said, though, it's amazing how the human brain works, because even though we've got it there and we've set it, it's amazing how we still want to get down and not do it. And I think that's a real challenge in flight training. And I think this is where we have an opportunity to really put out safe pilots, is right from the get-go, get it ingrained and say, you know what, there's no shame in overshooting.
There's no shame in going around. If it doesn't look good for any reason, punch the power and give it another shot. There's absolutely no shame in that.
The problems I see, especially with with primary students, is that they're flying a oscillating approach that varies tremendously in airspeed, and no two approaches are really the same. One's wildly high, one's frighteningly low.
If you're high, you're constantly struggling to make it. If you're low, you're constantly readjusting. And so it's not to say that you can't make great landings out of lousy approaches, but it's that if you want to make consistently good landings, you have to have consistently good approaches.
If you fly a standard approach right down the middle of the plate, 1.3 times VSO, in line with the runway, on the glide slope, it's easy to make consistent landings. But at the same time, if you're wildly high, if you're slow, if you're fast, there are all these other variables that you're trying to eliminate right at the point of touchdown, your chances of a successful landing are greatly reduced. It becomes a dramatic maneuver that requires some perfectly timed control inputs to salvage, and that is not what anybody wants.
A way to help that is to reduce as many of the variables as you possibly can. So that's why we start talking about things like pattern altitudes and why those are important. That's why we talk about putting in flaps at the same time every approach when you're first learning, or setting a power to exactly the same level every time. Now, of course, as you get better and get more experience, you can change 2 or 3 variables at a time, because you know how those variables interact and you know what sort of result you'll get by changing them. But until you learn that, it really helps to only change 1 or 2 things at a time.
Good landing should require little drama. But there's no big heroics and there's no great timing. It's just you fly into ground effect, you wipe off the power, and you are at an attitude that is just a regular transition to landing. It should be smooth. It should be pretty dull. It should not be exciting. It should just be a continuation of a series of steps that have begun long ago during the approach phase.
The base to final turn is often taken for granted as part of a routine traffic pattern. But stalls during this turn account for 10% of all fatal maneuvering accidents. A pilot's determination to force the airplane back onto the final approach course after overshooting the turn can have tragic consequences as the airplane stalls without enough altitude to recover. It doesn't have to be this way.
The base to final turn is, of course, a problem. We hear a lot about stall spin, and part of that is because people overshoot it and do the whole, too much rudder to compensate instead of aileron. Oftentimes, I think it's because people don't anticipate they're going to have a tailwind on base, and so they turn base and immediately they're through base and past final. Other times their turns are too timid. People turn in like 10, 15 degrees in the pattern when they should be more like 30. If you are turning coordinated and you're banking properly, there's no reason that you shouldn't go beyond 20 degrees in the pattern. I think it's an instructor's way of saying, well, we want to make sure that you don't have a stall here, when really probably what's going to happen is you're going to turn 20 degrees, realizing that you're overshooting, and then you're really going to crank it in. And because you don't know how to do steep turns at that point, that's when you're going to have a problem.
we tend to have this belief that once we swing wide, oh, we shouldn't be here, so we've got to get back. And that's where the problem starts. Rather than just saying, okay, I've swung wide, let's just straighten out and get ourselves out of here, they tend to now try and correct a situation that potentially is bad. And of course, the way to correct when you swing wide on final is first let's have aileron input, and then you find the aileron input really isn't working. So then the tendency is let's push more rudder, because that will bring me around some more, kind of pull me around. But of course, while the thinking might be that, what's actually going on aerodynamically is quite dangerous. And we're getting into a situation now where we're already in a banked attitude. We're not coordinated anymore. The angle of bank has probably increased beyond 30 degrees. And so we're typically in a situation where that inside wing is going to stall. And if we're already yawed because we've been pulling the airplane around with rudder, now we've got a stall with yaw condition, which, as we all know, is a spin.
In a left pattern, when pilots realize a shallow bank will result in an overshoot, they tend to kick in more left rudder to tighten the turn. This will bring the nose around, but it also increases the bank angle and rate of descent. Not wanting a tight turn so close to the ground, many will use opposite aileron to decrease the bank angle while pulling back on the yoke to slow their descent. Uncoordinated use of left rudder, right aileron, and increased back pressure on the yoke will increase the angle of attack on the inside wing while increasing the load factor. A stall and possible spin on the inside wing is imminent.
People bungle that turn because their head's down. They're looking at then they're flying mechanically. They're saying, okay, I want to be at 1700 RPMs. Their head's looking at, their eyes are looking at the tachometer. I want to have the flaps at 20 degrees, and they're looking at the flap handle or they're looking at the flap indicator, and your eyes, you need to have them outside so that that you won't miss the visual cues that are obvious when you're when you're paying attention to them of when to turn final.
Some of the visual cues occur well before the base leg of the pattern. If you're flying the downwind leg and you notice yourself being pushed closer to the runway, this should alert you to a wind speed and direction that will push you through the base leg faster. This is a common reason pilots overshoot the base to final turn. As you prepare to turn onto final, try to imagine where the extended runway center line is. This is where you should be completing your turn and rolling out to be lined up with the runway on final approach.
But for the most part, we're looking outside, and that means noting where you are in relation to the runway. If you find that you constantly overshoot that base to final turn, maybe you need to extend or widen your pattern a little bit.
And I think the way to avoid it, it goes back to the basics again, where a proper sight picture and also stressing during training that, if we swing wide, we live with it. We just accept it. Don't try and get yourself back. Obviously we want to get back, but the thing is, let's do it properly. Let's straighten ourselves out, look at the situation. Where are we? Where do we need to go? Are we able to do it safely? If we are, fine. We'll make the adjustment and then we go. But if we're not, just straighten out. And that's hard because, it's kind of, you get a fixation in your mind that, no, that's where I want to be. And sometimes it's hard to say, no, you know what, it's okay to go around, or it's okay. So what's the big deal? We messed up a little on this one. It doesn't matter. We'll just go around and we'll get it right next time.
At least 25% of all landing accidents can be attributed to a pilot's loss of control during a crosswind landing, or more precisely, the pilot's inability to manage the aircraft correctly during a crosswind. So it's no wonder that new or inexperienced pilots, or even pilots who haven't flown in windy conditions in a while, are intimidated by strong crosswinds when trying to land. Pilots are taught the proper way to land in a crosswind during their primary training and are required to demonstrate the technique to pass their check ride. Some are taught to crab the airplane down final and kick it over before touchdown, and some are taught to side slip it all the way down. Both methods are correct. However, at some point they will have to cross-control the aircraft to land on the upwind wheel first, and many pilots can be timid about this maneuver. And rightly so. In training, pilots are taught that cross-controlling is bad, but that is only half the truth.
The fear is real, yes, because the fear is real if you are not exposed to it early on.
Probably the biggest reason why people struggle with crosswind landings is they feel uncomfortable just being uncoordinated. We spend so much time telling people not to fly uncoordinated because you could stall and spin, especially at low air speeds. And then we turn around and tell them, okay, well, on crosswind landings, we're coming in at a slow air speed, and we want you to cross control at the end. So I think a lot of people just have a really difficult time feeling comfortable with doing that. A tendency to not put in enough correction, I think, is what you end up with at the end of the day, because they just have a hesitancy to put it in and hold it in. So they'll take it out, and then you end up landing in a bit of a crab. You'll know that that's the mark of a good pilot and good crosswind landing is that you've landed on the upwind main first, and then the other main, and then the nose.
Furthermore, while the control movements for a crosswind technique are usually taught correctly in the classroom, they may not be taught or practiced enough during actual crosswinds above 10 knots. Whether due to lack of windy conditions during training or an instructor's reluctance to train on windy days. As a result, many pilots never gain the experience of landing in a strong crosswind during training, and therefore never learn the proper sight picture of what landing in a strong crosswind should look like from the pilot's perspective. Once a pilot experiences what the attitude of the aircraft in relation to the runway looks like, with one wing dipped into the wind and the nose aligned with the runway center line, they can respond with the necessary control inputs to land safely. Having this proper sight picture is the key to becoming aligned correctly with the runway before touching down in a crosswind.
It all has to do with sight picture. Where is the center line in relationship to the nose? Find the spot on your cowling where it is perfectly centered. And remember, get that spot, burned into your mind. And so then don't let that spot waver back and forth. If you see the airplane move off the center line from side to side, ailerons. If you see the nose or the center line moving around the nose, rudders input. So the ability to coordinate those comes with experience.
One of the hardest parts of this maneuver is knowing just how much correction to put in and keeping it in place. With gusty winds and changing flight conditions, however, pilots soon realize how important it is to stay ahead of the airplane. Controlling an airplane in a crosswind, especially when it's low to the ground and slow, is a very dynamic process.
There is no set inputs of what it takes. It's just you have to experience it by going out and practicing it yourself.
With shifting and changing winds, there's not a whole lot you can do other than reacting to the feel of it. And it takes some time and practice to develop that feel, but it's definitely, you're dancing on the rudder a little bit more when there are stronger gusts. You're playing with the ailerons a little bit more to kind of fine-tune it and tweak it.
There is a point in time where if you get a strong gust, smooth controls inputs don't belong, not at all. So that means that you have to be aggressively make those control inputs opposite to what the wind is doing to you.
The wind will change significantly as you get closer to the runway. So regardless of even if you put in that forward slip way out on final, odds are you're going to have to tweak it. You're going to have to change the amount of rudder that's in there, amount of aileron that's in there as you come down on final, especially if you've got a tree line that once you get past the tree line, all of a sudden the wind sort of dies down a little bit because the winds are being blocked by the trees. So now you're definitely having to adjust anyways.
Learning how to improve crosswind technique, like any other maneuver in flying, requires practice. But practicing crosswind landings doesn't necessarily mean touching down in a crosswind.
The way that I practice with my students is to fly low over the runway with no intention of landing. And we tell them that no intention of landing, maybe keep on a little extra speed. That makes them feel a little more comfortable with the whole thing. And then just fly low over the runway in the crosswind correction, wing low, rudder to straighten the nose with the runway, and just fly right down the runway that way.
If you release the rudder pressure, the airplane is going to drift to one side. If you release the ailerons, the airplane is going to drift from one side to the other.
Being close to the runway like that, you can actually see when you're drifting. And it's easier to tell if your nose is centered with the center line of the runway. It always pays to go up and practice and take an instructor up with you and push your limits just a little bit beyond what you're normally comfortable with an instructor on board so that it maintains the safety. Personally, I think that this is one of the things that people should do on a flight review. As long as you've got a flight instructor sitting there with you, take the opportunity to practice the things that you're not as comfortable with or you don't do as often.
Once that airplane is on the ground, it's important to keep that crosswind correction in there. In fact, pilots need to realize they will require even more correction since their control surfaces are not as effective at slower speeds.
The tendency is, if you're in a stiff crosswind, we tend to, we're down, relax. And we relax the controls, can neutralize the controls, and our feet get a little lazy, and then we get caught with a good gust of wind, and it startles us.
Even if they get the landing correct, I think that sometimes there's a tendency to feel like, okay, I'm on the ground, I can relax now. And so when they do that, then they take out the controls, and then a wing dips over. So they don't follow through with the landing. Just because the wheels are on the ground doesn't mean you can stop the crosswind correction. As a matter of fact, you're going to be putting in more and more aileron as the aircraft slows down, but a lot of people kind of quit right when the wheels touch the ground.
There may be some occasions when the wind is just blowing too strong to land. For example, what should you do if you've run out of rudder and still can't keep the nose pointed on the runway center line? Sure, there are pilots who pride themselves on landing a Cessna 172 in a direct 30-knot crosswind. But you have to ask yourself, are you willing to become a test pilot?
I'm a safety person. I'm very safety conscious. I have nothing to prove to anybody. All I want to do is get my family and myself safely from one point to another, and I'm not going to be a test pilot when I do that, and I'm not taking risks with them or myself.
It's imperative that you do have the mindset that not every crosswind landing is going to go well, that you may have to make a go-around out of it.
And if you've run out of rudder and you've run out of aileron and there's nothing more to give and you're still not centered up with the runway, that's when you go around and you find an airport or a different runway that's more closely aligned to the wind. A go-around is called for any time you don't have a stabilized approach. Anytime you have that little voice in your head that says, I think I've got this, I think I can make this work. Anytime that comes into your mind, then you go around.
A short field landing, put your mind outside the airplane for a minute. You want to transition this air vehicle to a ground vehicle using the minimum amount of space on the ground. So once you think about it in the terms of what you're trying to accomplish, then the how to do it becomes really pretty clear. You want to approach at as slowly as you possibly can in the maximum drag configuration that you can, and transfer that weight to the wheels as quickly as you can.
The biggest myth with short field landings is that, at least for the test, that it's all about landing as short as you possibly can, and so people are constantly dragging it in, you know, doing a little weed whacking on their way to touching down on the very edge of the pavement and making the turn off, because, you know, that's what Chuck Yeager would do. But the FAA expects us to turn the short field landing technique into a spot landing technique. And that's really what it's about. So it's, I'm going to aim for the spot and I'm going to hit that spot. And because we're talking usually about obstacles with short field landing, typically that approach is going to be steeper even than normal. If you have a Cessna with you know, the 40 degrees of flaps, it makes the process actually really easy, because you go that huge amount of flaps, you know, that deploy the barn door, you slow to 60, and then it's really a power off, steep down nose approach to the transition, and then you hit that spot.
And then once you touch down, you'll want to raise those flaps and brake aggressively to use the minimum distance.
There's a tendency to forget to bring the flaps up, or they apply the brakes incorrectly, they skid, or sometimes they just forget.
You want to touch down as quickly as possible. That plane decelerates quicker when its wheels are on the ground than it does in the flare.
As a pilot examiner, what I see is the speeds are all wrong. A lot of students and candidates make the error that they consistently approach at the same speeds no matter what type of landing they're doing. And I don't know kind of where this comes from. But we have to remember too that in the books, typically the speeds that are given to us are based on a full up weight. And you have to remember that when it comes to landing an airplane, you want to land at the slowest possible speed commensurate with safety. And if you don't weigh 2,300 pounds that day and you're down at 1,900, approaching at your 70 or 75 is just not going to do it for you.
If you think about it, if you remove yourself from the cockpit, you look at the big picture, you get outside the airplane, then you've got less potential of being confused. If you're only thinking about the mechanics of move this control, move this set of controls here and there, it's easy to miss the big picture and see what you're trying to accomplish.